One of the most widely occurring kinds of inflorescence in flowering plants, and one that's found across many flowering plant families, is the spike, where you have a large number of individual, generally small flowers clustered at the top of the flowering stem. But they mature successively from the bottom of the spike upwards, so that at any one time, over several weeks, you have receptive flowers for visiting pollinators, greatly maximising the chances of cross-pollination. Now, almost all of our native wild orchids have spikes, and there's no more elegant example of this than the fragrant orchid. The only other orchid you might at least initially confuse with the fragrant orchid is the pyramidal orchid. But in that species, the spike is more compact and squat. It's actually more of a cone than a pyramid in spite of the name, and it's always some shade of a very distinctive magenta colour. But when it comes to the scent, the two flowers are very different. The pyramidal orchid has that strange foxy smell, but to our noses at least, the smell of the fragrant orchid is much more pleasant and much stronger. And it appeals, more importantly, to a different, equally long-tongued cohort of pollinators that includes the small elephant hawk moth, the hummingbird hawk moth, the silver Y, the burnished brass, and lots of other species. But to be more accurate, when the flowers of the pyramidal orchid first open, there is a faint smell of clove oil from them. You can see the way the older flowers, already pollinated and setting seed, are at the bottom, arrowing upward to flowers at the top that haven't yet opened. The flower is similar in its structure and workings to a pyramidal orchid. You have the three outer tepals or sepals, two of which form the wings on either side, and the third, along with two of the inner tepals, forming a hood that covers the column in the centre of the flower, with the prominent three-lobed lip or labellum at the bottom. The front part of the labellum is angled forward, but the back part is a horizontal landing platform, white in colour, in front of the entrance to the long, slender nectar spur, on either side of which, at shoulder height, moth shoulder that is, are the two stigmas. Between the two stigmas are two transparent adhesive pads, the visidia, which immediately attach to the insect's head as it probes for nectar. Then, as the moth steps back, the pollinia, at the top of the column, each in a little vertical shroud, are withdrawn because they are attached to the adhesive pads by slender threads known as the caudicles. When they are withdrawn, the pollinia swing slightly to either side because, although in their shrouds they are parallel to each other, they are under tension. Then, over the next minute or so, they move slowly forward so that they will be exactly where they need to be to strike the stigma of the next flower visited. Presumably, the abundance of nectar means the insects spend a sufficiently long time at each flower. It's not really possible to simulate this, because no pencil or probing needle is anything as delicate and precise as the proboscis of the moth. Carnation and clove oil are among the scents that are especially attractive to butterflies and moths. And in no other wildflower is the scent of clove oil stronger than it is in the fragrant orchid. In fact, on a warm day in July, in a place where fragrant orchid is abundant, the scent simply fills the air. The smell is due to a chemical called eugenol, which is quite widely used in food preparation, especially in cake making and for teas. And it has a long-standing and well-deserved reputation going back many centuries and still today for curing toothache. So, if on a dark winter's day you want to attempt to recreate the sensory experience of walking among scented orchids in July, all you have to do is to open your little bottle of clove oil, close your eyes and inhale.